Hi, this is Stephanie Conklin. I'm here to talk to you about a geometry lesson called Circles Are Everywhere, which you can find in my Circles unit. We'll start class with a Do Now question, which gives teachers an opportunity to get a sense of their students' recollection of key terms related to circles, including diameter, chord, and radius. And students have a chance to identify those key parts in a picture. Once teachers have gone through those words with students, on the first page of class notes, you'll find a list of the key vocabulary for parts of a circle, including center, radius, chord, diameter. And I find that secant and tangent tend to be new words for students, so teachers definitely want to take a little time to unpack those words and help to give students some tips on how to identify the difference between a secant going all the way through a circle, and a tangent just grazing or hitting one point along the circle. After that, we'll give students a chance to really apply and make sure that they know those keywords, doing a pair share, where they have to identify the key parts of a circle in a picture that I provided in the notes. Then we're going to jump into a really important standard relating to this unit, and that's the idea that we'd like all students to realize that every circle is similar. And so to actually start us off, we're going to connect this with another really important idea in the geometry curriculum, which is congruency. So I've provided for thinking questions, and students can either turn and talk to each other, which I find really works well, and jot down some ideas for the questions, or students can just independently think about how the two circles are related. So I've prompted students with the first thinking question: are these two circles congruent? Why or why not? And one's small and one's big. So hopefully all students will realize they're not. And students can then try to think about how would we be able to show if two circles are congruent. And I would really encourage teachers to try to push students to think about this visually. So anytime we don't have a picture, we want to make a picture. And this is a great opportunity for students to maybe draw a picture, especially if they have their compass, of two congruent circles, and then they can try to identify what would make these congruent, and hopefully they'll realize that having the same radius or having the same diameter would be one of the important things to having two circles that would be congruent. But then we want to push students to think a little bit further, and if you look at the end of the page 2, I've given an example for how we could think about, before I give the example, I've given a definition for similarity, and one definition of similarity is that similar figures, we have two shapes that could be similar if a set of transformations will move one figure to completely cover the other one. So in the first example, which teachers can lead students through or do on their own, we'll ask students to draw a circle with center -1, 2, and a radius of 3, and we want to see if we can move that circle to cover a different circle P. And hopefully what students will discover with some thinking questions following up is that all we need to do is do a translation and then a dilation, which is a set of transformations, to show that every circle is similar.